Here's our last example of a system of linear equations in two variables. We want to find that ordered pair solution that works for both equations. Once again, our equations have fractions. So the first step we're going to go through is we're going to eliminate those fractions by choosing the multiplier of the least common multiple for those denominators, least common denominator. In this case, that would be 10. In this case, it would be 20. I'm going to take every term of the first equation multiplied by 10. Each and every term gets multiplied by 10. 10 times 2/5. 5 will go into 10 2 times. 2 times 2x gives me 4x. 10 times 1/2 is 5. 10 times 13 halves. 2 goes into 10 5 times. 5 times 13 is 65. 20 times 3/4. 4 goes into 25 times. 5 times 3x. It's going to give me 15x. 1/5 of 20 is 4. And 20 times 17 halves. 2 goes into 20 10 times. 10 times 17 is 170. Ooh, some big numbers we have to mess with here. But the approach doesn't change, even though the numbers are larger than we have been facing before. Now I need to make one of those coefficients for the x's or the y's to be positive and the other one negative. Well, unfortunately, these are both positive, these are both negative. The least common multiple here would be, what would we have there? 60 for 4 and 15. And the least common multiple here is 20, so let's work with the y because we'll be dealing with smaller multipliers. So I want to let's make this coefficient become plus 20y. So we would have to multiply it by -4, wouldn't we? And if I want to make this one stay minus, I will multiply by a positive, and I want it to be minus 20, so I'll multiply by 5. Let's see if I can do these multiplications in my head without making a mistake. -4 times 4x is going to be -16x. Minus to minus is plus. 4 times 5 is 20y. This is going to be negative. 4 times 5 is 20. Put down the 0, carry the 2. 4 times 6 is 24, and 2 is 26. So -4 times 65 should be -260. Now let's multiply by 5 here. 5 times 15x, that's going to be 75x. Minus 20y equals, 5 times 100, that's 500, and 5 times 70 should be 350. So 500 and 350 would be 850. 5 times 17 is 85, and then a multiplier of 10 would be 850. A little tougher, we got into these bigger numbers. The y's disappear for us. Now we need to add these terms together. -16x plus 75x. Let's see, is that going to give us 59x? 9 and 6 would be 15, 5, 6, 7, yes. And -260 plus 85, well, let's see. If we do the subtraction, 0 from 0 is 0. 6 from 15 would be 9. And 2 from 7 would be 5. Oh, that was kind of nice. And so now, we solve that equation for x. We get x equals 10. So the x value is 10 in the ordered pair solution to this system. Now we want to find the y value. Are we going to put the 10 back in one of the original equations that had the fractions? No way. We're going to take the 10 and put it into one of the equations that no longer had the fractions. Let's put 10 in for x here. 15 times 10 will be 150. So 150 minus 4y equals 170. If I subtract 150 from both sides, -4y equals 20. finishing out by dividing by -4. So the ordered pair solution for that original system is the ordered pair 10, -5. Once again, when I was confronted by fractions, I multiplied through by the least common denominator for each equation in order to eliminate the fractions and then solve that equivalent system to find my ordered pair solution. This is the addition-elimination method, one of the algebraic methods, the one used most often when finding the solution to systems of linear equations.